Good morning dear students, I Himantrias welcome you to your physics class. Students, today we are learning about further types of semiconductors on the basis of conductivity. So over here there are two types of semiconductors. First is intrinsic semiconductor and the second is extrinsic semiconductors. Now what are intrinsic semiconductors? If the semiconductor is in the pure state, it is called as intrinsic semiconductor, whereas if the semiconductor is subjected to doping, means doping is a procedure in which we are adding the impurities, then it will be the extrinsic semiconductors. Now these extrinsic semiconductors are further of two types. First is N-type semiconductor and the second is P-type semiconductor. So let us first discuss about N-type semiconductors and what do we mean by that. So students, you should know that in the N-type semiconductors we have when we talk about any type of semiconductor, we have charge carriers, and these charge carriers are of two types. The first charge carrier is the electrons and the second charge carriers are holes. Electrons are negatively charged and the holes are positively charged. For N-type semiconductor, as the name suggests, N stands for negative. Now, how will we make these semiconductors? If this is negative, means majority current will be carried by electrons. Means electrons are responsible for the current. But how? So let us take one example. If I have one semiconductor, now this semiconductor can be germanium, this semiconductor can be silicon, made up of silicon or germanium. Now if I am adding to it some group 13 element which have a pentavalent impurity, like if I say arsenic, antimony or bismuth. So these are actually those types of atoms which have more than 4 valence electrons. So these are those which have more than 4 valence electrons. Now you know that these arsenic, antimony as well as bismuth, all of the three are coming in the nitrogen family. So these are included in the nitrogen family. We know nitrogen, phosphorus, arsenic, antimony, bismuth, all are there. So actually these are present in the group number 15. So pentavalent impurities we are taking from group 15 which have more than 4 electrons. Now why we are talking about that they should have more than 4 electrons? So there is a logic behind it. We say of group 14 because all the semiconductors are from group 14. This group 14 is of carbon family and the maximum valency that the carbon can show is 4. So if I want to make a semiconductor which have more electrons, means electrons are more than holes, means the negative charge is more. So how will I make? Suppose there is one case, 4 bonds are made between the atoms. So we know that 4 electrons are consumed in the semiconductor doping to make these bonds. But now we require the N-type semiconductor, means we require more electrons, means we actually require free electrons. How will we get that? So because of that, what we do is these 4 electrons, we take some metal which have 5 valence electrons. Because if I talk about silicon will make 4 bonds, and if I take some pentavalent impurity like arsenic, so arsenic has now 5 electrons. So one bond is this, 1, 1 and 1. So these are 4 bonds and this will be one extra electron. This will be that extra electron which will be made between the impurities and the semiconductor atoms. Now because of this free electron which is present will contribute to the current. So this will contribute to current. Now let us take another example where we are taking now the P-type semiconductor. how we can make the p-type semiconductor. Let us understand it. For that, what do we require? We require group 14 atom as usual, because this is only our semiconductor. Now along with it, what do we require? We require now one trivalent impurity. Now why I said because I require a trivalent impurity. Now I require something which has an electron deficiency. This will be only trivalent impurity, means group 12, group 13. The examples over here included are aluminium and boron. These can make 3 bonds, and maximum of 3 bonds can be made. So now here we will understand the concept of holes. Now see how this is my silicon atom, and this can make the 4 bonds. So these are the 4 bonds that it has made, and here is my aluminium. We know aluminium can only make 3 bonds. So if one is here, one is over here, and one is over here, now it cannot make any bond over here. Means we know that now this space will remain empty. So now what will happen over here? So here there will be one extra electron, and remaining all bonds will be formed. Now this extra electron will require something to be captured over here. So what it will do is, here this extra electron, because it has now nothing over here, now here one hole is created. This is one hole. Now what happens is, because to fulfill this hole and to make this bond, the electron from the neighboring bond comes over here. And now if we see the structure, it will be like, this is my silicon atom, now this is my aluminium atom, here is the bond made. Now this silicon is satisfied, but what do we see? We see now the aluminium can make no bonds over here. So now because of this, holes are now more than the electrons. So here the current which we see will be formed by the holes. So holes are positive in nature, so the current will also be positive in nature, and that's why we can say that here the semiconductor is of p type. Afterwards, in a doped semiconductor, there is one equation so that you have to learn. In doped semiconductor, the equation is NeNH equal to Ni square. What is Ne? This Ne is the number of electrons. NH is number of holes. And what is this Ni? Ni is the number of intrinsic charge carriers which are contributing to this current. So number of electrons, number of holes, and the intrinsic charge carriers. So NeNH equals to Ni square is our equation which we have to learn. You also know now there are some cases, like if I talk about N-type semiconductor, what is there? We know that now here electron number is very more than hole number, and for P-type semiconductor the whole number will be very more than electron number. These are the common things that you have to learn. Now how the electrical conduction will take place through the semiconductors, let us learn about that. Suppose I have one of my semiconductors placed over here. This is my box which I assume to be a semiconductor made up of silicon. Now what will happen is, if I am adding here a trivalent impurity like the aluminium, so we know how it will be. Here will be the electron and here will be the hole, and rest all of the atoms will be formed. Now what is happening is, as I am connecting this with the battery, this is my battery which I am connecting. Here it is positive, here it is negative. Current will flow in this direction and flow from here in this direction. So we can see in this whole of the box, what do we see is, as the current is entering from here and leaving from here. So suppose here is our potential A and here is our potential B. We know that potential A at A will be greater than potential at B. So here it is a greater potential and here it is a less potential. Now we know what is the tendency of the electrons. The electrons always move from the lower potential to the higher potential. and the positive charge carriers will always move from the higher potential to the lower potential. So over here, what do we see? We see that as the potential is higher over here and lower over here, so the holes will move towards this side, and the electrons, which I can show in different color, will move this side. So this is the electron movement and this is the hole movement. Now these are my holes and electrons which are moving in the opposite direction, which are contributing to the current. Now what will be the total current which is formed over here? Total current will be the current contributed by electron as well as the current contributed by holes. So I equal to IE plus IH is my final equation over here, where the electron current and the hole current are together forming the total current of the circuit. Now when we talk about the conductivity of the semiconductors, there is one important relationship which you have to learn. This is that the conductivity is given by sigma, and it is Ne mu Ne multiplied by charge, that is E, mu E multiplied by mu E, plus NH multiplied by charge multiplied by mu H. Now let us understand what are these all the terms. So if I talk about over here, this Ne is the number of electrons, this E is the electronic charge, and this mu E is the mobility of the electrons. Similarly over here is the NH, E and mu H. Now let us talk about what do we mean by mobility. So what is mobility? Mobility is the potential which we have applied upon E, that is the electric field. So this is mobility, which is denoted by sigma. This sigma is equal to 1 upon rho, and this will be equal to E, as we are taking it common, Ne mu E plus NH mu H. So this is one important relationship that you have to learn, that mobility will be equal to E multiplied by Ne mu E plus NH mu H. You have to also learn that for germanium and for silicon, the energy gap, that is Eg, for germanium it is 0.72 electrovolt and for silicon it is 1.1 electrovolt. These are the two values that you have to learn. So that's all for today. Thank you and have a nice day.